national educator.
Welcome viewer to Physics Form 3. My name is Mr. Seto. Our topic today is linear motion, and the subtopic is the equations of linear motion. The objective, or what I would want you to achieve by the end of this lesson, are you should be able to derive the equations of motion. You should be able to apply the equations of motion in linear motion problems that would follow. Now, the equations of motion shows the relationship between the following parameters that you had learned in the previous lesson: displacement, which is distance in a particular direction; initial velocity, which is represented by u, is the rate of change of displacement with time at the beginning of the motion. Then we have got the final velocity, represented by the letter v. This is the rate of change of displacement towards the end of the motion. Then the acceleration, which is represented by the letter a. Acceleration is what we are going to look at today in depth, but in the previous lesson you had defined acceleration as the rate of change of velocity. And then the last parameter is time. Time is represented by the letter t, and I usually remember all these parameters by a simple acronym, and the acronym is goes in with the name SUVAT, where S stands for displacement, U stands for initial velocity, V stands for final velocity, A stands for acceleration, and T stands for time. So, as we had, I had asked you before, and you stated it in the last lesson, acceleration is actually the rate of change of velocity with time. So therefore, we have got a final velocity minus the initial velocity divided by time taken within the flight. This could also be seen on the motion graphs. So if we look at the motion graph that we have there, you see the vertical line, which represents the y-axis, has got velocity, and the horizontal axis has got time. And then you can be able to see the way time is changing and velocity is also changing. So change in velocity there is represented by v minus u, that is final velocity minus the initial velocity. When you divide that by the change in time, you get gradient. You remember in mathematics you said that gradient is the rate of change of y divided by the rate of change of x. So that gradient is what? Is our acceleration. So let us move on and see how this is going to help us get the equation of motion. So since the change in y over change in x, which is the gradient of that graph you had seen, is equals to final velocity v minus u over t. That is the gradient which is equivalent to the acceleration. So therefore, a is equals to v minus u over t. That means any acceleration, if you're given acceleration, you can be able to find velocity or initial velocity or final velocity or time, depending on the type of question.